We continue part 2 on slide 10 with figure 3.5. In figure 3.5, we evaluate the shape of the indifference curve. We have clothing plotted on the y-axis and food plotted on the x-axis. The indifference curve is downward sloping and convex in shape. All along the curve, as food increases, the amount of clothing decreases. Remember that it cannot slope upward, as a consumer is meant to prefer more to less. If an indifference curve sloped upward, a consumer would be indifferent to a bundle where in fact more of both goods are possible. So in fact, the curve is downward sloping, and this follows on from the assumptions that more is better than less. With a nonlinear curve, we know the slope changes all along the curve. The magnitude of the slope of an indifference curve measures the consumer's marginal rate of substitution between two goods. We will explain this term in a moment. The shape tells us how a consumer is willing to substitute one good for another. Let's look at the following points. If a consumer were to move from point A to point B, the consumer would be willing to give up 6 units of clothing to obtain 1 additional unit of food. We can see that the change in clothing is given by 16 minus 10. And that additional unit of clothing we can see as plotted on the horizontal axis. And again, if we were to compare points B to point D, we can see that there is a change of 4 units of clothing. So clothing would fall by 4 units for the consumer to obtain 1 additional unit of food. Similarly, from D to E, we can now see that there is a change in clothing of 2 units to obtain 1 more additional of food, and so forth. You can also examine what happens between E and G. So how do we define the marginal rate of substitution? It is the maximum amount of a good that a consumer is willing to give up in order to obtain 1 additional unit of another good. Consider the diagram we just looked at. The maximum amount of clothing the consumer was willing to give up in order to obtain 1 additional unit of food. Therefore, the marginal rate of substitution of food for clothing is the maximum amount of clothing that the person was willing to give up to get that additional unit of food. If the marginal rate of substitution was 2, for instance, the consumer would be willing to give up 2 units of clothing for 1 more unit of food. It shows the value the person places on that additional unit of another good. For consistency, we define the MRS in terms of the amount of the good on the vertical axis that the consumer is willing to give up in order to obtain 1 more of the good on the horizontal or x-axis. What does the convex shape of the indifference curve imply? The term convex means that the slope of the curve increases as we move down the curve. You saw this, that it became less negative as we moved along the curve. Therefore, we can say an indifference curve is convex in shape if the marginal rate of substitution diminishes along the curve. The slope falls in magnitude. We see the marginal rate of substitution fall from 6 to 4 to 2 and so forth. So this decline in the marginal rate of substitution reflects our 4th assumption regarding consumer preferences, a diminishing marginal rate of substitution. When the MRS diminishes along an indifference curve, the slope or the shape is going to be convex. The shape of an indifference curve shows a consumer's willingness to substitute one good for another. So a different shape means a different willingness to substitute. There are two extremes cases, you could say, and those are perfect substitutes and perfect complements. Perfect substituents occur when two goods for which the marginal rate of substitution of one for the other is constant. We will see what that means graphically in a moment. Perfect complements refers to when two goods for which the marginal rate of substitution is zero or infinite, and then the indifference curves are shaped at right angles. In all our examples thus far, we have considered goods, as in a product that you would always prefer more of. However, there are bads, a product for which less is in fact preferred to more. And an example of such is air pollution. So, in instance like this, will our assumptions continue to hold? And the answer is yes. However, the product will be redefined to ensure that consumer preferences are still represented. So, for instance, the preference would become for clean air, and therefore our assumptions would continue to hold. In figure 3.6, we are going to see the two extreme cases of perfect substitutes and perfect complements. In figure 3.6a, we have perfect substitutes. In this case, we have Bob, who views orange juice and apple juice as perfect substitutes. So he's always indifferent between a glass of one for the other. So in this case, the marginal rate of substitution of apple juice for orange juice is 1. The slope in each case is constant. The MRS is constant, as it can be seen as these are all straight line indifference curves. In figure 3.6b, we have perfect complements. Here, Jane views left shoes and right shoes as perfect complements. An additional left shoe will give her no extra satisfaction unless she's going to obtain the matching right shoe. So in this case, indifference curves we can see are shaped as right angles. The MRS for the two goods are either 0 or infinite. So if there are, for example, more right shoes than left shoes, then the MRS of left shoes for right is 0. You won't give up any more left for right shoes. And if there are more left shoes than right shoes, the MRS is infinite. You will give up all but one left shoe to get one right shoe. Please read through example 3.1 regarding the preferences for automobile attributes as a useful example. So far, we have not attached a numerical value to the level of satisfaction. We have just used indifference curves to show consumer preferences graphically. Recall the indifference map earlier on in the chapter. Consumer theory relies on the assumption that consumers provide us with relative rankings of market baskets. It is, however, useful to assign a number value to a basket. In economics, the concept of utility refers to the numerical score representing the satisfaction a consumer gets from a given market basket. A utility function is a formula that assigns a level of utility to individual market baskets. Let's have a look at figure 3.8. The particular utility function, let's have a look. The utility function is a function of food and clothing is equal to FC, and it is given by the figure 3.8 as an example. And this tells us that the utility is given by the product of FC consumed. Utility is a function of food and clothing. So if we just look at the variables in the brackets, remember when you were to read coordinates, you would read your x first and then your y. So now we know that our food would be plotted on our horizontal or x-axis. Remember that in future when you see a utility function as such and you need to determine which is plotted on the horizontal and the vertical axis. A utility function can be represented by a set of indifference curves, each with a numerical indicator. In this figure, we have three indifference curves with utility levels of 25, 50, and 100 associated with this particular utility function. Let's look at U1 with a numerical indicator of 25. At point A, we can see that food is 5 units per week and clothing is also 5 units per week. Thus, if we look at our right side, FC, which is this utility function, it's multiplicative. 5 multiplied by 5 would give us a utility of 25. So similarly, we can check the other points. At point B, we've got 10 units of food, and it is in fact 2.5 units of clothing, and 10 times 2.5 would also give you 25. It would also yield that value. The second indifference curve, U2, would contain baskets with combinations of FC yielding 50. And the same then can be applied to U3 with combinations of baskets yielding 100. The numbers attached to these indifference curves are more for convenience. The utility function is simply another means to rank different mass baskets. In figure 3.3, you were given an indifference map. Market baskets were ranked in order from most to least preferred. However, by how much A as a market basket was preferred to B was not indicated. This is ordinal utility. An ordinal utility function is a utility function that generates a ranking of market baskets in order of most to least preferred. If numerical values are assigned to market baskets, and if it had meaning, it would be said that we have cardinal rankings. A cardinal utility function is a utility function describing by how much one market basket is preferred to another. However, it must be stressed that these numerical values are arbitrary and making interpersonal comparisons is impossible. The following example, 3.2, Can Money Buy Happiness, can be found on page 103. Please read through this example on income and happiness to further your own understanding. We will continue part 3 on budget constraints in the next part.